S3, S4 Physics, Circuit Rules. Circuit rules, series circuits. There's only one path for current to flow in a series circuit. Here we have a series circuit, and we can see there's only one line for the electrons to flow. So current goes around the wire following a single path. From practical work or research, series circuits can be shown to have the following rules. The current is the same at all points, or we can use an equation. IS, that's the current from the supply, is equal to I1 is equal to I2, and so on and so forth. It's important to note that this relationship is not on the relationship sheet. We also have that the sum of the potential differences, that is the voltages across each of the components, is equal to the potential difference, the voltage of the supply, or, again as an equation, Vs is equal to V1 plus V2, and so on. Example. State the value of the supply voltage in the following circuit. We have our supply, and we're told the voltage across each of the components, 4 volts across each lamp, and 2 volts across the resistor. We use the relationship Vs is equal to V1 plus V2 plus V3, thus giving us a supply voltage of 4 plus 4 plus 2, which is 10 volts. Circuit rules, parallel circuits. In a parallel circuit, there is more than one path for the current to flow. We call each of these paths a branch in the circuit. So we have our supply, and then we have 3 branches coming from the supply. And each of those branches represents a separate path for the current to flow. Again, from practical work or from research, a parallel circuit can be shown to have the following rules. The sum of the branch currents is equal to the supply current, or IP is equal to I1 plus I2. IP is the current coming from the supply, I1 and I2 and so on represents the current going through each branch in the circuit. Also, we can say that the potential difference, that is the voltage across the components, is the same for all components, or Vp, voltage of the parallel circuit, is equal to V1 is equal to V2. So in the previous circuit, each of the branches would have the same potential difference measured across them. Example. State the reading on the ammeter A4 in the following circuit. We have our supply, a current of A1 is measured at 7 amperes, 3 amperes goes through A2, 4 amperes goes through A3, and therefore, within those 2 branches add up, current A4 is going to be the same, it's going to be 7 amperes. We can think of it like runners in a race. Some runners go through one path, some runners go through another path, but all the runners finish the race. 7 runners start, 3 goes one route, 4 goes another route, all 7 end up at the finish line. Circuit rules, review questions. Question 1. Student sets up the circuit below to demonstrate the way lamps are connected inside a caravan. State the voltage across lamp 1 and lamp 2. Well, we can see that this is a parallel circuit, and the rule for a parallel circuit is voltage in the parallel circuit is equal to V1 is equal to V2. Therefore, we can say that the voltage across lamp 1 and the voltage across lamp 2 are going to be the same. So voltage, lamp 1, is going to be the same as the supply, and that's 12 volts. We're also asked to find the current in lamp 2. Well, we know we have 5 amperes here. 2 amperes came from this branch, which means the rest of it must have come from this one. 5 take away 2 gives us a current in lamp 2 of 3 amperes. Question 2. Circuit is set up as shown. The reading on ammeter A1 is 0.5 amperes. State the reading on ammeter A2. The fact that we see the word here, state, that's a command word. That tells us that we should know the answer and is only worth 1 mark. Because this is a series circuit, we can say that supply is equal to I1 is equal to I2, and so on. All of the currents are the same. Therefore, if A1 is 0.5 amperes, A2 is also 0.5 amperes. Question 3. A circuit is set up as shown. Here we can see a series circuit. All 3 voltmeters have the same reading. Is this true or false? Well, the rule within a series circuit, Vs is equal to V1 plus V2, and so forth. Voltages in a series circuit add up to the supply. So it's impossible for all 3 voltmeters to have the same reading, because V1, measuring the voltage supply, is always going to be bigger than V2 and V3, because in this example, V1 is equal to V2 plus V3. Question 4. A circuit is set up as shown. Now this is more difficult. This is a mixed circuit, so we have series elements and parallel elements to it. All 3 ammeters have the same reading, true or false. Well, we can see the current in A1 is in the series part of the circuit. Now current A1 must come from current A2 and current A3, because the currents in a parallel circuit, remember, current parallel is equal to I1 plus I2, so on. So that means that A1 being measured here must be greater than A2 and A3, because in this example, I1, the current measured by ammeter 1, is equal to I2 plus I3. So this is false. Question 5. Circuit is set up as shown. State the potential difference across R1 and the current in R2. So we can see that this is a parallel circuit. Therefore, the voltage across each branch is going to be the same. And that's the same as the supply. So voltage across R1 is going to be 12 volts. 6 amperes is coming from the supply. That's split between the branches. 1.5 amperes goes through R1, which means the current I2 through R2 is going to be 6 minus 1.5, which is 4.5 amperes. Question 6. A circuit is set up as shown. We can see that this is a series circuit. We're told the current in the lamp is 1.5 amperes and the voltmeter reading is 6 volts. State the current in the resistor and the voltage across the lamp. Well, because it's a series circuit, the current's the same at all points, so the current in the resistor, I for the resistor, is going to be equal to 1.5 amperes. The voltage across the lamp is going to be equal to the voltage supply, take away the voltage across the resistor, which is 9 minus 6, giving us 3 volts. Question 7. The student suspects ammeter A1 may be inaccurate. Ammeter A2 is known to be accurate. Which of the following circuits should be used to compare the reading on A1 and A2? Well, obviously, we want to see a circuit where the values for A1 and A2 are going to be the same to check the accuracy of ammeter A1. So that must be the series circuit, which is circuit B. Here's a summary of the answers. And you can use these to go back and review your learning. So here's our past paper question. A circuit is set up as shown. We're given readings for A1, A2, and A4. So let's just mark that onto our diagram to help us. A1 is equal to 5 amperes. A2 is equal to 2 amperes. And A4 is equal to 1 ampere. Which row in the table shows a reading on ammeters A3 and A5? Well, ammeter A1 is in the series part of the circuit. So that current, 5 amperes, is flowing all the way along this line and goes into the branch. When it gets to the branch, it's going to split. So that means 5 amperes splits. 1 ampere is going to A4, which means current for A5 must be 5 minus 1, which is 4 amperes. Current then comes together, and if we were to put an ammeter here, we would measure a current of 5 amperes. That 5 amperes then splits. 2 amperes goes to A2, which means A3 must be 3 amperes. A3, 3 amperes, so that's wrong, that's wrong, that's wrong. We're looking for a value of A5 to be 4 amperes, so that's our right answer. Correct answer is going to be D.